Hello, welcome back to Cheenta Statistics and Data Science, School of Statistics and Data Science, and we'll be going to discuss the assignment problems. And we are doing currently testing and hypothesis in our classes, platinum classes, and as discussed as planned, we'll be discussing the problems that are being given as assignment in this class. So let's get started. Guys, do you have any doubts in the problems that we have given, or I will select randomly and discuss as per my wish? Yeah. And till now, what you have done? We have done LRT, and have you done other things like Neyman Pearson lemma? Yeah, you have done Neyman Pearson lemma.
Yes.
Okay, perfect. So let's get started. Let's do this problem. Okay, let's do this basic problem first. This one assignment. This problem revolves around the fact that observe. Okay, let's discuss the problem first in this way. So x1, x2, xn is a sample of size n from Bernoulli P, and it's given that we have to test. We have to test the hypothesis that P is equal to 0.49 versus P is equal to 0.51. So using a central limit theorem, determine approximately the sample size needed so that both the probabilities of error, that is type 1 error and type 2 error, are about 0.101. Okay. So using central limit theorem, in this by central limit theorem, I mean that like you have to assume the sample size is large in some sense, otherwise it will not happen, So sorry guys, we got disconnected, and we will be starting soon again. Just give me a minute. You can hear me clearly now, I hope. Yep. So here, okay, so I will be sharing the steps here. So understand that First of all, understand this very carefully. We have, what are the objects we have in testing hypothesis? We have a null hypothesis H1 versus H0 that we have over here, this one. And then we have type 1 error. What is type 1 error? So then we have the rejection criterion. Rejection criterion or region. That is reject H0 if some which is given over here. And one of the main aspect of testing hypothesis is to find this rejection region, the UMP, the best powerful test, the most powerful test sort of rejection region. So here it's told that it's greater than C is the criteria of rejection. But how much greater than C, it's not given. It's the rejection criteria. So we have to find the C first, rejection region. So this large, so how much large, it's not given. And it's given the type 1 error. So usually the type 1 error is fixed alpha, and we have to minimize the type 2 error. So what is type 1 error? The type 1 error is the rejection region, which is called R. So probability that xi's belong to R given H0 is the rejection region, and probability type 2 error is probability xi does not belong to R or belongs to R complement given H1 is true. Here in this case, it is nothing but probability summation xi greater than C. We don't know the C, okay? We have to find out the C first. So using the information that this type 1 error probability is 0.01, we can find out the C. Given P is equal to 0.49, it's equal to 0.01. And from this, we will find out the C. We'll find out the C. Number one. And often the problem is that we don't know what's told about, okay? And we will be using some central limit theorem, because you know that summation xi is what? It's a discrete. So greater than C, you will be having a, not a perfect view of that, C, perfect C value. So there will be always, it's not the exact. So we need to approximate it by central limit theorem into normal, and then we will calculate that probability. That's the idea. And we will get the C from here. Okay. So, and once we get the C, so let's find out the C first. And once we get the C, it will be easier to find the R. So let's see. Probability summation xi 1 to n is greater than C given P is equal to 0.51. Okay. We have to find this. It's equal to 0.01, right? We have to find this C. How do we find this C? We approximate. It's given hints that summation xi by n under H0. Okay, remember under H0. Under H0, that is P is equal to 0.51. Summation I from 1 to n xi by n, this is x n bar, minus P, okay, by what is the variance of this? The variance of this is this. The variance of x bar. So what is central limit theorem? Xn bar, all IID, minus P by variance of Xn bar, right? We calculate in terms of it, this goes to in distribution to normal 0, 1. So here we say that we observe that summation xi, that is Xn bar, minus P, that is 0.51, by what is variance of Xn bar here? So its variance of Xn bar is nothing but variance of x1 by n. It will be root over, sorry. Root over variance of x1 by n, since all are IID. Okay? Prove this. And you can easily prove that. Why? Because summation all the xi's, it will be n times the variance and by into 1 by n. So as it comes out, it will be 1 by n square. So that will be variance of x1 by n. So 1 by n square and ऊपर n है, so n and n square is cancelled to 1 by n. Like I hope you understand this, like this stuff now, because I mean this step jump should be understandable by you at this point of time. So this will be root over variance of x1, which is nothing but p into 1 minus p. Since all of them are Bernoulli, okay, remember all of them are Bernoulli, p, and by root n. So we multiply it by root n by root over p into 1 minus p, 0.51 into 0.49. Very good. So this is converging to normal 0, 1. Okay. So what we'll assume? We will assume this behaves like z. This will be assuming. So how we'll write this? Assuming central limit theorem, CLT by CLT, xn bar minus 0.51 by root over 0.49 times 0.51 times root n. This behaves like z, that is the normal 0, 1, standard normal. And then what will be going? We will be doing summation xi by n, so minus n times this. Okay, behaves like z times 0.41 times 0.51 by root n over here, okay, plus this. So we can sort of do it like this. Yeah. Plus this. So this is xi. So therefore, the radiation region was what? Summation xi is greater than c. So radiation region here is n times 0.51 plus z times this 0.51 times 0.49 by root n greater than c is the radiation region. Given h naught already is incorporated over here because we have put p. So the radiation region is this n times p plus, so it can write it as np plus z times p into 1 minus p by root n. This is the radiation region. So under h naught we have put p is equal to 0.15, 0.51. This is the rejection region, and we have got that this greater than 0, this greater than c. So oh, नीचे बहुत जाएगा, हाँ. So let's write it down below. So we have to transform in terms of standard normal. So it's z greater than c minus np times root n by root over p into 1 minus p. So you have to find this c out, and probability of this must be equal to 0.01. So you know, you can therefore write it in terms of what? The quantiles, the normal quantiles, which value you know. So you can write it as compared to normal quantiles for which value of this is equal to 0.01, and you can get a value of n. Okay, you can get a value of n. Sorry, you can get a value of c in terms of n. So from here you will get a value of c in terms of n. Okay, so now you put that value of c over here in this. You put the value of c in this, and you have to calculate now probability summation xi less than c. Given p is equal to 0. Oh, it will be 49 now. So okay, sorry, this will be 49 instead of, so this will be 49. This will be remaining same. So from here you can calculate this opposite probability given p is equal to 0.51. Okay, and that's the idea, right? It's rejected. No, oh, it's type 2 error is it's not rejected, yes. So this given this is equal to 0.01, And you can calculate this now again in terms of, it will be now in terms of what? N. So this probability in terms of n, by equating it to 0, you will be getting a function of n is equal to 0.01, and you equate it will be a quadratic in n, and you get it to find the n. Okay. Did you understand the strategy, guys, how to solve this problem? Yes, I saw that, Shana, thank you. Did you understand the strategy, how to solve the problem step by step? Any doubts? Others? Okay. Nikhil? Okay, very good. So let's move on to the next problem. It's a very easy, so it's a step-by-step manner, so it's not a very hard one. So let's go to the next problem. Show that okay, the problem asks you to show that for random sample x1 x2 xn from normal 0 comma sigma square, the most powerful test for this, where this is given, that sigma 1 is greater than sigma naught, is given by this. Okay, that means this is phi. That means you reject if this happens, if you accept if this happens. So the most powerful tests, you know how to do the most powerful test, right? How? Can you tell me what theorem will you use? What idea will you use here? You will use the NP lemma because it's simple versus simple. So use NP lemma. So use NP lemma. So what do you do? It's normal for 0 comma sigma square. So let's write it down. This will be C. This will be C. Okay, it's very easy. So by NP lemma, what does it? I hope you have learned NP lemma, right? So by NP lemma, what do you get? You get the following, that you do f1 of, so you do find joint distribution of likelihood for under h1, and you find the joint distribution of likelihood under h0. It will be sigma equal to sigma 1 here, so it's normal, right? So here you get what? It's product of super v product, inter v product. So you can write it as product together. Okay. ऊपर क्या है? ऊपर 1 by root 2 pi sigma 1 by नीचे 1 by root 2 pi sigma naught, and it's exponential minus half xi minus 0, that is xi, you can write it as xi by sigma 1 whole square by exponential xi by sigma naught whole square. Okay, and if you get this out here, you get, so as you know from NP lemma, that we will reject h0 when this is greater than c, right? That means this h1 is sort of dominating over h0, then only we reject h0, right? So for some c which we don't know that c, okay, so let's write it down then properly. So it's equivalent to saying product of this 2 pi cancels, the sigma naught, these are constants, okay? So these are also constants, it doesn't matter. So it's like this. So you can always take out the constants outside. So you have a big C over here, which is a constant, or a K over here. It contains all the constants. For your, for mathematical simplicity, you can assume that. And it's product of I from 1 to n. This terms will be constant, so it's exponential. You can understand now, it's half common xi square, so we can do xi square by 2. Here you have what? You have this constant 1 by sigma naught square by 1 by sigma 1 square. Right? It's greater than some c. And if you observe it very carefully, we get, this is only, we are finding the rejection region now, guys. We are finding the rejection region. If you do the product, you get summation, or sorry, you get exponential. This is a positive quantity, exponential. This is a constant, right? And we will see how this constant plays a role. You will see it in your eyes, okay, now, just right now. This constant is very important. I from 1 to n. Okay, there's a half over here. Xi squared greater than c. So we have two constants. What are the constants? The constants are k. So let's call it k1 times exponential k2 times summation xi square I from 1 to n greater than c. Write the constants like this. It's really helpful in your mathematical calculations, guys. So when you write like this, where k1 is what? K1 is nothing but sigma naught by sigma 1, and k2 is nothing but half times 1 by sigma naught square minus sigma 1 square. Why I've written like this, you will understand it slowly. So now this is a relation region, and therefore we get that, observe this k is greater than 0. So when we take it over there to get, let it some c dash, or call it c1, the inequality sign never changes. So this k2 times summation I from 1 to n xi square, and we have now exponential is an increasing function. So what you do is the following: you take log because it's invertible, right? And you take log and you just give me a minute. You take log and therefore you can take log because it's positive, of course. K2 times summation 1 by n xi square greater than C2 because we have taken log of it. Now comes the best part. Understand this very carefully. How this is so coherent with the basic idea. Now understand, if, see, observe it over here. What does the intuition say? If sigma naught is less than sigma 1, that means you will reject when the xi tends to be higher. Summation xi tends to be higher, summation xi square. The sample average, sample variance tends to be higher in some sense. You reject, like this, if the sample variance tends to be higher, that means it's more favorable towards sigma 1 because sigma 1 is greater than sigma naught. If sigma 1 is less than sigma naught, then we will reject if sample variance is lower, then summation xi square is lower. Here why I'm telling sample variance, that is summation xi square, because mean is 0 over here, that's fine. So therefore observe this very carefully. K2 is greater than 0, so observe this is greater than c. Now this is equivalent to two cases, that summation xi square is greater than c2 if and only if k2 is greater than 0. That means if and only if sigma 1 is greater than sigma naught. And summation xi square, you reject it if this happens, C3, if and only if K2, because if K2 is negative, the sign opposite sign changes, right? If and only if sigma naught less than sigma 1. And it's very natural. If sigma naught less than sigma 1, sigma 1 greater than sigma naught greater than sigma 1, it's very natural. If sigma naught greater than sigma 1, that is H1 is lower. That means you reject if this is lower, the sample variance in some sense. And you reject the H0 in this case if sample variance is more. So you see how these two are coherent, guys, with each other. Did you understand this? Did you understand this? The whole thing is coherent with each other. the whole theory, and this is one such example. Did you understand the whole calculations, guys? We have done using Neyman Pearson lemma.
Calculation fine, but this last thing about sample variance being lower, can you repeat that?
Sure. So here, this is a philosophical thing. So if H naught is sigma is equal to sigma naught versus H1 is sigma is equal to sigma 1. Let's call it any sigma 1, sigma, any. Let's give it a constant. So let's 1 versus 2. And we'll do another case where H naught is 1 versus sigma is 0.2. One second. Now, observe that what is a good estimate of the sample of the actual variance? The sample variance, right? But here the mean is 0. So a good estimate, like, of a good estimate of sigma is what? Summation xi minus mu, because mu is 0 over here. So it's 0, summation xi square 1 by n, right? There's a good estimate of this. So therefore, we will reject if this is more, this is larger, okay? That means if it's more than, let's say 3, then we reject it. The larger it is, that means the higher the rejection is. So therefore the rejection region is this, the rejection idea is this. Now what C we don't know. Similarly here we reject if summation xi square is less than san C. What C we don't know, because the rejection region, the H1 is lower than H0. So this is the rejection idea. Now the question is that this is exactly what is coming out. If sigma 1 is greater than sigma naught, we reject when the rejection region is of this form. And sigma naught is greater than sigma 1, that is, we reject when the rejection region is of this form. Did you understand now, Nikhil? Or not?
Yeah, I got it.
Okay, all of you understood this, guys? Shana, Mansi, Polami, Rishabh, or do you want me to explain it more? Okay, very good. Okay, so this is the basic idea. Okay. Okay, so therefore you understood that the rejection region, this is a phi, the rejection region is rejected, it's rejected if this is a rejection, 1 means rejected, 0 means not rejected. 1 if rejected if this is greater than C, which is natural since this is greater than 0, sigma naught. Okay. Just give me a minute. Let's do this problem now. It's a hard problem. Have you done likelihood ratio test, guys? Have you done likelihood ratio test? Yes or no?
Yeah, we have done.
Okay, good. So what is likelihood ratio test? I will just revise once again so that you understand the question. Likelihood ratio test is the following: that we have this one where this is a function of data, the random sample, and it tells you that if this supremum over theta belongs to the H naught region, that is denoted by this, that is this parameter, like where the parameter lies. Here in this case it's mu, theta is equal to mu, so that is just mu. Supremum, the joint distribution, the likelihood, by the supremum of the entire sample space of the likelihood. Understand that this is less than equal to 1, but it's always less than equal to 1 because supremum is taken over a bigger space, which is a subset of this. It's always less than equal to 1. So we reject H naught if what? If the probability, the probability of the likelihood under H naught is very, very less compared to the actual, at the this, this maximizes the MLE. This is the exactly the supremum is just we are calculating the MLE, right? The value of the likelihood at the MLE. So we reject H naught if the supremum over the H naught, the null hypothesis, is really, really small with respect to the actual one. If this is really less than equal to C. Does it make sense? Do you understand this? Why this is true? Do you understand why this is true? We reject in this case. Yeah. Do you understand it? Good. What about others? Great, great. So therefore, reject if this in this case. So therefore, we have to find out the LRT. Let's find out the LRT. So understand the test can be written like the test means the rejection region can be written just in terms of this T. Let's find out. So we have this two equations, x1 and x2 over here. So it's a hard problem. Hard problem is that it's not only x1 but also xy curl also here. So there are two samples. So the likelihood, let's calculate the upper one. The likelihood, let's say under H naught. Under H naught, okay. So let's calculate just theta and mu. What it is. So it's just nothing but exponential theta and exponential mu, assuming it's red parameters. So observe that it's nothing but what? Product of 1 to n, theta to the power n to the power exponential theta xi, वहां पर j m are there, m of them are there. So वहां पर j from 1 to m mu to the power n exponential lambda yj, right? This is this. Let's write it down properly. Yes, this is the basic idea. Okay. And yes, this is the basic idea. So the upper one, the supremum, that theta is equal to mu under this, let's find it out, of this is nothing but in 1 to n. Theta is equal to mu, so let's replace it by theta only. And here it's j from 1 to m, theta to the power m exponential, this will be mu, I'm so sorry, exponential mu yj Okay, and this is under theta is equal to mu. They're independent. They're totally independent. That's why we can write like that. So we have found this out, but we have not found a supremum. We have not found the supremum. For which xi it happens? We have not found that. So this is supremum. This we will find it out soon. So how to find it out? How to find it out? You have to find it out by differentiating with respect to theta only, because theta is existing everywhere. It's a parameter. If you to find out supremum with respect to theta, that's the only parameter over here. So we need to find the supremum of this. So here, what is the function? The g theta of x curl comma y curl is nothing but this theta to the power n, or we can write it as theta to the power. It will be m. I'm so sorry. I think this is something. This will be just theta, not theta to the power n. It will be just theta. So here now you can write it as exponential. Observe that it's theta is coming n here, m here, so it's m plus n. And here उसके बाद supremum है, ठीक है? Exponential. This is summation of, that is theta summation of I from 1 to n xi. There's another theta over here plus summation of yi from 1 to m yi. ठीक है? This is what we have got till now. Exponential theta sum came, it's summation xi, and here exponential theta common, summation xi, summation yj, sorry. And theta m times here, so theta to the power m, here theta m n times theta to the power n. Did you understand this equation, guys? This is a bit more involved, just to make you comfortable with the whole idea. Did you understand this, guys? This g theta of x curl y curl. Did you understand? I'm asking you because it's mathematically more involved. That's why. That's the only reason. Oh, nice question, because that's the LRT. Theta is equal to mu. Here there are multiple parameters, two parameters, theta and mu. That's under H naught. Sorry. Did you understand now? Yes. So I've taken a theta is equal to mu. That's the H naught. Because here the parameter space is nothing but both parameters. It's a theta curl. We can call it as theta comma mu. And now it belongs to H naught, means theta comma theta format. Okay. Did you understand now? Shan and others. Mansi, Paulami. Oh yeah, you're right. You're right. Yes, it will be minus. Thank you. Thank you for this. Any other doubts, guys? For others? Mansi and Nikhil, Rishabh. Rishabh, it's clear? Very good. Okay, so we have it over here, and so now we have to make it supremum with respect to theta. You can understand. We have to make it supremum with respect to theta, because that's the supremum. Theta is equal to mu. Over that, now theta is a single parameter, so we have to make it supremum with respect to theta. We have to maximize it with respect to theta. So we need to do just take log of it. ln g theta of x curl comma y curl log. So you get m plus n ln theta plus, sorry, minus theta. Okay, so since you understand that you have to write this in these two formats, right? So let's give it a name. let's call it A and A plus B. Okay, let's call the xi is A, summation xi is A, and summation yi is B to make an ease of the whole notation. As you can understand, this will come up in their own way here. So here it's nothing but A plus B. This is what you have got. Now you have to maximize it. And so take the differentiation. So we take dl d theta is equal to 0, which will turn out to be m plus n by theta minus a plus b. And if you take another derivative, you will see that it's minus negative, so it's maximum. So it implies it's equal to 0 implies that theta is nothing but m plus m by a plus b. It's just theta hat. So what we will do, we'll now replace this theta hat over here to get the upper value. You see how complicated it is? It's a bit complicated. So now what we'll do is that it is just calculating. So if you do lambda x, upper is lambda 1 x curl, lambda naught, here it's lambda, you call it lambda 1 x curl in this sense. So we are just calculating now upper, just the upper one, the numerator. The numerator is now, observe, this is the maximum, this is where the maximum happens, m plus n by a plus b. Now we'll get put this theta back into this expression. This is the g theta. This is this expression we have computed in this manner to get the maximum value. To get the maximum value, okay? So we put that back. That is this. That is theta hat. That is m plus n. Okay, let's write it out. Let's write down theta hat only. M plus n exponential. Observe that it's exponential minus theta hat again a plus b. Okay. So m plus n by a plus b. Okay, m plus n is nothing but so theta is m plus n by a plus b. The supremum value we are putting now, whole to the power n plus n exponential. Here minus m plus n by a plus b, so it's just minus m plus n. Okay, a plus b get cancelled. So this is the upper numerator ka maximum value. Did you get till this point of, guys? Did you get till this point of time? Did you understand till this point? Any doubts? Any doubts? We have got the maximum. We have got the maximum value of the numerator. We are just putting back the maximum values. So step number 1, you find the likelihood. You find it in terms of one parameter. You find the maximum value by differentiating, taking the log, and find the point where it's getting maximum and put that value into the likelihood to get the maximum likelihood, like the max supremum value. That is, you do it for the numerator, just for the numerator. Did you understand, guys? Others, Shaina, you understood? What about others? Nikhil, Paulami, Rishabh, did you understand? It's very intricate. That's why I'm asking over and over again. Rishabh, are you understanding? Super. So this is the upper wala you have got. So now see, this is a constant. This is a constant. So this will not be mattering. So you can take this as a constant. So remember, there we have, we need at least 2 ones. So I'm writing it here. So this one is comma y curl is nothing but by. So here we have got what? We have got this one. Observe that it's m plus n whole to the power m plus n into exponential. That stuff that is not required at all. Just don't, that is a constant. So you can write it as k1. You can write it as k naught, let's say. K naught times, the main idea is in this format. into 1 by a plus b whole to the power m plus n. This is the main idea. And let's calculate therefore the lower hand term. So upper wala is done. So let's calculate this one, the lower. The lower one is, you can observe, it's theta is not equal to mu, and it's actually over the all space. Okay, so we need to maximize with theta and mu both. You have to maximize with theta and mu both. So now, let's write down the whole likelihood once again. It is with respect to theta and mu both. Okay, it's like the whole parameter space. So it's, you can understand, it's 0 to the power n times mu to the power n m times exponential, if you observe, minus theta summation xi, you can call it a. Okay, just a because it's in terms of a. Here exponential minus mu, it's in terms of b, right? All of you got this one? I have written in a different format, guys. Did you understand this form, guys? Did you understand this form? It's this is what we are, the actual one, the likelihood of x and x curl and y curl. Do you understand? I have replaced I written in a different format. Okay. What about others? Do you understand this one? It was in product format. I've written in summation format. Do you understand, Nikhil and Paulami? Paulami, did you understand? If you don't understand, please tell me. It was in product format. I've written in multiplication, written in terms of something that is required in the problem. So now we have to maximize it with respect to theta and mu both. And you can say it's product of two. You have to maximize both of them individually, okay? Because they are, they're in product format. So maximize both of them, and you can understand maximizing both of them simultaneously, sort of maximizing this, because they are not dependent on each other. It's maximize supremum over this times supremum over this. Because you can easily understand they are like two different independent stuff. Okay, because they're independent, IID. So maximize the likelihood of x and y if xi's or yi's are independent is same as maximizing the likelihood of x times maximizing the likelihood of y. So we are finding the likelihood of this. Did you understand, guys, here, this idea? So therefore we are maximizing over this. So now this niche wala one, x curl, y curl, is nothing but supremum over theta to the power n exponential minus theta a times supremum over mu to the power m exponential minus mu b. Now you can understand how they are maximized. They are maximized at the MLE, right? They are maximized at their MLE. Right, guys? They're maximized at the MLE, right? If they're maximized at their MLE, both of them are maximized at their MLE. This MLE is what? The rate parameter MLE is what? Do you remember? What is the rate parameter MLE? Mean ka MLE is x bar. The rate parameter MLE is what? Theta ka MLE is what?
X bar by n.
Mean ka MLE is x bar. So theta hat ka MLE is, theta is the rate, 1 by x bar, right? So it's n by summation xi.
Yeah, that's what
And mu hat ka MLE is m by, so it's n by a and it's m by b. So therefore, if you put it over here, you get theta hat ka MLE, that is n by a whole to the power n times exponential, observe, n by a times, this is again constant. So that is a big constant that is in K2 times, you see it's 1 by a whole to the power n times 1 by b whole to the power m. This is the maximum likelihood. Right? Very simple, right? Very, very simple. Great. So we have got what? So this is the upper wala part, supremum. So we have got, therefore, here it's divided by k1 times 1 by a to the power m times 1 by b to the power n. Sorry, n and m. This must be less than something. Did you get it, guys? Everything you got it till this point of time? It was a super interesting, beautiful, and intricate problem. If you get this, that means you have understood the whole idea thoroughly. If not, then you may be having some issues in your understanding. Did you understand this, guys? Shana, Nikhil, Rajesh, Paulami, and Rishabh? Good, very good. Very good, super. So let's see now. Let's see. So K1, K2 is gone. They are positive also. So we have a to the power n times b to the power m by a plus b whole to the power m plus n. It's less than c. So this is how it is being, this is a rejection region. But the second form is being told, the second part tells you that so the test can be written in the base of the statistics a by a plus b. Just a by a plus b. Just a by a plus b. And it's very easy. Can you tell me why? So observe the a by a plus b by a plus b is equal to 1. So let's call it t a and let's call it tb. So ta plus tb is equal to 1. So observe this, that you can write it as a by a plus b whole to the power n times b by a plus b whole to the power m less than c. That means ta whole to the power n times 1 minus ta whole to the power m less than c. This ta is equal to t actually. So we can write the equation in terms of t. Did you get it, guys, the solution of this? How we can write the whole equation in terms of t? It's very beautiful. Do you understand that? Yeah, very interesting, very easy. What about others? Ptolemy, please reply quickly. I mean, it's really hard to call your name every single time. Okay, so the last part is find the distribution of t when h naught is true. That is, theta is equal to mu. That's very easy. Summation a that is under h naught. So what? Theta is equal to mu. Okay. So t is what? Summation xi by summation xi plus yj. Right? So under theta is equal to, and these are exponential. Again, okay, so under h naught this follows exponential theta, let's say. So summation yi will follow what? Summation xi and summation yi will follow what? Tell me. It's very easy, man. What they will follow? What they will follow? Quickly, very quickly, at this point of time. What
Gamma.
they will? Gamma, very good. So they will follow gamma n comma theta. And here it will follow gamma m comma theta under h naught, and their sum will follow, since they're independent, gamma m plus n comma theta. It's very easy. So they will follow what? It's gamma n comma theta by gamma m plus n comma theta. What is the distribution of this, guys? Follow. Do you know any distribution, known distribution of this?
Beta second kind.
Okay, so what is beta second kind?
Means the parameters.
Yeah, so tell me, like, what is the beta distribution? What is second kind distribution? Tell me.
Oh, so the second kind.
Your voice is getting cut.
Yeah, so the second kind distribution is that x to the power alpha minus 1 by 1 plus x to the power alpha plus beta.
Wait, like, how is it related to gamma distribution? Tell me that.
Means that ratio gamma n by theta and gamma n plus n, means ratio of to gamma will be beta.
Okay. That was n. Just give me a minute. Yeah, you're right. So yeah, so it's related to beta second kind. So what is beta second kind? Beta second kind, yes. So the relationship is, although I mean I don't know like if this is really useful in the examination or not, but you should be knowing it. Beta second kind is the following. It can be, it's, so normal beta is what? X to the power 1 minus alpha into 1 minus x to the power 1 minus beta, right? So now Paul, let me tell you what is beta second kind, how it's different from this. How it's different from this.
Okay, for that will be x to the power alpha minus 1 by 1 plus x alpha plus beta.
Yes, so this
Is beta alpha comma beta.
minus alpha plus beta.
Yeah, and that will be 1 plus x.
That will be 1 plus x, I'm sorry. This is beta second kind. And how it's related to gamma distribution. So you can find this out in terms of, in terms of, find out the moments and all this stuff, but how it's related to gamma distribution. Can you tell me the, proper result?
If x follows gamma something, y follows gamma something, then the ratio x by y.
Okay. So how many parameters are here? Like in beta distribution, how many parameters are there and how many parameters do you need for beta second kind?
There'll be two parameters.
There are two parameters. There'll be two parameters. So it's called actually beta prime distribution in some sense. So you can read it out that if So this beta second kind is same as beta prime distribution. So beta prime distribution can hold multiple parameters, generalized ones. So what you find out is you do your homework and you read this about this beta prime distribution, and because there are multiple parameters over here, m, n, and theta. Okay, so you need to find out beta prime. What is that beta prime distribution? So find out this beta prime distribution. What is the relationship with it? You find it in Wikipedia. Okay, and that's exactly the same as the second kind. So you find the relationship with this. Also, you don't expect this kind of problems in IIT, so don't remember this, but this is something for your knowledge. Okay, all of you understood the problem, the entire solution problem. It's a really intricate problem, delicate problem. Did you understand that, guys? All of you over here. So we will move on to the last problem of today then. All of you understood the problem, except if it's okay if you don't understand the beta one. Yeah, very good. What about Shana? Do you understand? Second problem. Which problem? Second problem. This one? The part B? Before? This one? Okay, let's see. Oh, okay, this is very easy. Okay, so we have found out this. Okay, so now, okay, the question is, show that for a given alpha, you can find out the value of C. Now you tell me, Shana, how will you do this? How will you do this? How do you find the value of C from here?
So, sorry, C, I thought it was E.
No, it was not E, it was C. So
Okay, so then okay.
it's like, it's not, you can find out now probability of rejection, summation xi square greater than C given H naught. That is.
Yes, so now I understood. I thought it was E.
Okay, no worries. So this is alpha, so you can find out in terms of C this in terms of this.
Okay.
Yeah, perfect. Okay, so let's move to the next problem and the last problem. Okay, so it's about comparing two just give me a minute. So x1 x2 follows theta comma theta plus 1, and for testing theta is equal to 0 versus theta greater than 0, we have two competing tests. This is phi 1. The two tests, the rejection regions is, the one is reject h naught if x1 greater than 0.5 and x1 greater than c, the c which is not known, find the value of c. So the question is that find the value of c such that these two tests have the same size. Size means alpha, type 1 error. So let's calculate that. It's very easy. So A part, type 1 error, that is probability rejection of h naught, that is x1 greater than 0.95, given theta is equal to 0, is equal to probability x1 plus x2 greater than c given theta is equal to 0, right? So we know this, so it's equal to what? It's equivalent to saying that x1 is greater than 0.0.95 and theta is equal to 0 is 0.05 is equal to probability x1 plus x2 greater than c given theta is equal to 0. So x1 plus x2 is 0. You can find out the distribution of x1 plus x2. It's called triangular distribution. So triangular distribution looks like this. Although the sum is from, yes, so it's from 0 to 2, though this maximum happens at 1. So you can find out the distribution now by by joint distribution. Okay, probability this. So it's integration x1 plus x2 greater than c. So it's like their IID. So it's 1, of course. dx1 dx2. Now how the x1 x2s are there? x1 greater than x2 c minus x2, right? x1 greater than c minus x2, and so this is the diagram. This is x1, this is x2, and this is the c. It's between 0 and 1. So you can easily understand this. If this is x1 plus x2 is equal to c, this is the height where you are looking for the area part, and you can easily understand that if this is c, x1 plus x2 is equal to c, then where does this cut? This cuts at let me just check. Here it's x2 is equal to 1, so it's, yes, so just give me a minute. So it depends actually whether c is more than 1 or c is less than 1. So I think we can do it in a different manner instead of the diagram. So x1 plus x2 is greater than c. That means x1 plus, okay, you see there are two different cases where c is greater than 1, where c is less than 1. Okay, and it's 0.005. So you can easily understand that within this area of 0.01, it will be c is really here, since it's the probability is really low. So it's really here. So it will be c is much more than 1. You can easily understand that. We are doing it geometrically. Okay, we are doing this geometrically. So c is it's 0.05. So c is really 0 here. So c is greater than 1. So you can understand there's a certain geometric tricks you can use in the exam, or but it's based on your intuition and knowledge. Okay, there's nothing wrong. So c is like this. So this is 0.01. If this is the c, then you will understand this point is nothing but c minus 1 comma 1, because sum must be c, and this point is nothing but 1 comma c minus 1. And this is, if this is case, then this is nothing but c, this length. This is 1 minus c minus 1. Sorry, what I'm doing. This is c minus 1. This length is c minus 1. This length is 1, so it's 2 minus c now. This length is 1, and this length is c minus 1. Right? So this is 1, this is c minus 1, so it will be 2 minus c. Similarly, it will be 2 minus c also. So therefore, this area, you can easily calculate it's half into 2 minus c whole square. Did you understand this geometric argument, guys? Did you understand this geometric argument? No, yes, maybe. Without calculating the integral. Did you understand the geometric argument or not?
The 2 minus c part I didn't get.
Sure. So here is the x1, x2 part, the square. So the region is x1 plus x2 is greater than c, right? It's uniform. So it's like uniform. So it's area which matters of this region. So here it's x1 plus x2 is equal to C. So this region is greater than C part. And understand the region is 0.05. So the region is very, very small. So like C lies over here. So if this is the case, this is the line, and this one is, this is from 0 to 1, this is from 0 to 1. So this one height is 1, x2 height is 1. So this point is what? The sum is C. So this point is C minus 1 comma 1. The height is 1. And here it's 1 comma C minus 1. Did you understand, Nikhil, this one? Did you understand, Nikhil and Rishabh, this one?
Yeah, got it.
So therefore this is length is 1. So this must be 2 minus C, right? Rishabh and Nikhil and Ptolemy and Shana. Yes, very good. And therefore this area is what? This area is half times 2 minus C whole square. So most people will not be doing it in this way, okay? Since you are intelligent people, you should be doing like this. This is 0.05. So you can find out the value of C from here. Okay, guys? Very good. So let's calculate the other part. I will give it some as homework too. So calculate the power function of each test. So that means it's less than 0.05 and you can find out less than C. And C is much more than 1. C is much more than 1. So you know that this is the x1 plus x2 is equal to C part. This is the one, C. Oh no, wait. No, it's given that power function of each test. Power function of each test. So it's x1 plus x1 is less than 0.05, 0.95. I don't know, like what C do we choose? That's the question. So confused in this. So why I'm confused about, why I'm like so much focused on this is due to one reason. Because for C greater than 1, it will be different. For C less than 1, it will be different. Okay, that's it. For C greater than 1, it will be different. For C less than 1, it will be different. Because x1 plus x2 is between 0 and 2, right? So that's the idea. If C is greater than 1, then it will be different. C is less than 1, it's different. So that's the idea. So the graph also tells so. If C is equal to 1, is this graph. C less than 1, the thing will be different. And C greater than 1, the thing will be different. From here, I got to understand. So if we assume this C at 0.05 point, so we can assume that C. Okay. If you assume that C, because no one else, it's given that this size has, so let's compute C is at this point only, okay, at this point C. So at this point C, okay, this is very easy. So now it's easy to calculate the whole thing. So this is the rejection region. So we have got this C at 0.05 level, the size. This is the rejection region. This is the rejection region. And this is the acceptance region. That means in this region, it's H1 is, here is H0, here is H1. This is the rejection region. So the size is this. So power is probability of this, therefore this is 0.05, so this is 0.95, right? This is 0.95 under H0. Remember this. So under H1, okay. So now let's take a difference, how to find the power function. The way to find the power function is to fix this theta is equal to this theta naught, and then find the power function. So what is the power function? the power P of theta naught is nothing but probability rejected, that is x1 greater than 0.95 given theta, and their probability x is equal to x1 plus x2 is greater than whatever the C I've got given theta is equal to theta naught. And in this case, you find out these two values given theta is equal to theta naught. Given theta is equal to theta naught, remember. Okay, and this will be a function of f of theta naught. And you plot that function. You plot that function. Now you have to calculate use the integral. There is no other way. And plot that function. Okay, and I think that will give you a good result. And then you find that whether which is more powerful. So now I give it to your homework, this one. Next day, if you can't solve it, we will solve it. Just let me know. Okay? It's a really interesting problem because it tells you how to get a test that has the same size, but one is more powerful. It gives an idea about the UMP test. Okay, it gives an idea about the UMP test. That's the idea. This problem gives an idea about the UMP test. Two tests have the same size, but one is more powerful than the other. So that's the idea. Okay, guys. So you complete this problem, guys, on your own and share your ideas, and I will get back to you next class. If you have phased out, I will get back to you with the solution. Okay, just let me know in the group. Okay, all the best, guys, and a very good night to you. And yep, thank you, guys. Thank you. And yep, so if you enjoyed the problem solving session, do like, share, and subscribe, and share it with your friends who really need this. And thank you, and stay tuned and stay blessed. A very good night to you. Bye bye.